What's up, everybody? Welcome back. Unit 5 Math, Worksheet 505. We are now going to look at calculating the inside volume of a cylinder. Okay. Well, inside volume, or say if we had a cylinder that we wanted to fill with bright blue water, maybe, we're looking at the inside volume. So if we're looking for the inside volume, we're looking for the inside diameter, which is fantastic. So the inside diameter is the skinniest diameter that we're going to use. So if you remember, we have outside diameter, which is outside to outside. We have mean diameter, which is middle to middle. And we have inside diameter, which is inside to inside. So for this one, we only need to think about outside and mean diameter. If we are having a thickness, we need to eliminate to find the inside diameter. If the inside diameter is given to us, we're just going to go ahead and use that. Okay, so we really only need outside and mean diameter as a way to establish what the inside diameter is. But let's go ahead and look at an example. Actually, first, let's talk about how are we going to find the volume. Maybe, Kevin, you should start talking about how to find the volume and not just what inside, outside, and mean diameters are. So we remember our equations from previous parts of this unit. What was the area? How did we find the area of a circle? The area of a circle was pi times radius squared. If this was a two-dimensional circle and not a cylinder, and there was no outside black line, just the inside blue, pi times r squared, right? So half of the inside diameter would be your r. So pi times that squared would give us the area. And then what was the volume? How did we get the volume of the cylinder? We multiplied it by the height of the cylinder. So actually the inside volume is the exact same thing. So if you just eliminate the thickness of this three-dimensional cylinder and think of it as just a round, tall, flat object, that will be the inside volume. So the equation is similar to what we've done in the past for cylinders, pi times r squared times height. Now all we have to do is find those numbers inside some sort of example question that I've created that we're ready to go with. So the question, what is the inside volume of this cylinder? Okay, so we're going to have a boo. We're looking for what is inside this cylinder. All right, what's in here? What do we got? What's in there? What's going on inside that middle piece? Not the thickness of steel, not the inside of not the thickness of concrete, whatever it's made of, just what is the inside. And to realize that, we need to remember, of course, that we need the equation pi r squared times height. Sweet sunshine. So now let's look for these numbers. We have, it is 1 meter tall, and we have a 500 millimeter inside diameter, but we've got pi and height, no problem. That diameter needs to be a radius, right? R means radius, D means diameter. Radius is half of a diameter. So what is 500 divided by 2? That would give us half of that. And that, of course, is 250 millimeters, right? So radius of that is 250 millimeters. So then it is a matter of writing out the equation, pi times 250 millimeters and 1 meter. There's another problem right away. Before I continue even going forwards, you'll remember every other unit I've done or that we've done together, we have always needed to convert into the same units when doing an equation, and it does not change now. If we have 1 meter and 250 millimeters and we're multiplying, I think we should change everything into meters. If we multiply millimeters, I've tried it in the past and I've always discovered that I end up with like 3,000 or 300 million or a billion, or some crazy number. So let's turn it into meters and keep everything nice and tidy. So I'm going to divide 250 millimeters by 1,000 millimeters per meter and get 0.25. So I do pi times 0.25, and my equation tells me it's squared, so I'll put that little 2 up there. Again, that just means 0.25 times 0.25. It is this button on your calculator matron, and then it's a meter tall, so it's just times 1, right? 1 meter is 1. That's pretty easy. And then I can go ahead and crank in an equal sign on the calculator. So pi times 0.25 squared times 1, and I get 0.196349541. Awesome. Sweet sunshine. And of course, if we are doing this in reality, we want a manageable number. Typically, we go to the third decimal. It's just a nice, easy place to be, especially in meters to millimeters, because that usually is something like in millimeters. So I'm just going to arbitrarily round it to the third decimal, 0.196. The 3 means the 6 stays the same. Meters, and that is cubed because we multiplied 1, 2, 3 things together. That gives me meters cubed in my answer. Okay, well, that seems pretty small, but it's only a meter tall and it's only 500 mil inside diameter, so it is pretty small. Let's look at something a little larger. So I did a concrete water silo up in Comox early in my career. These are not the dimensions, but it was somewhat kind of closer-ish kind of to this. And I was always wondering how much water was in that freaking water silo, because it was a beast. So, slip form, by the way. First slip form, that was really fun. Ask your instructor what a slip form is. So we've got a water silo that's 80 feet tall. Okay, let's see if we can... Sweet. Circle on the top. We got a couple of round legs here. We have a half circle on the bottom. We have another half circle here. Ooh, there you go. That's the world's squiggliest water silo. That would fail inspection 100% of the time. Okay, so then I can go like this, and that is 80 feet. Why do I always draw these out? That's because it's a lot easier for my brain to keep track of what's going on in the question if I draw this out and I have something I can label that I can keep track of. So for these questions, I like to think in chunks. This one, there is really only one chunk, so I'm just going to focus on the one chunk. But I like to draw a plan view and an elevation or a side view because it's easier for me to visualize what the heck is going on. So I'm looking at 80. I've got 36 inches thick, and I've got an outside diameter of 20 feet. Outside diameter of 20 feet. Or I could go like this as well. 20 feet. Okay, same thing. Now you can see I'm looking down on that cylinder. Before I even get started, remember the last one, I said we're going to turn all those millimeters into meters. We're always doing that. Well, I noticed right away I got 36 inches for my thickness. So I'm going to do 36 divided by 12 and turn that into feet. Then I've got feet and feet and feet. And I know I need a volume. I know I need 3 numbers. So I'm going to turn that into 3 feet. Now I know I'm okay for my equation. The equation for the cylinder in imperial is the same as it was in metric. That much doesn't change. Pi times radius squared times height. Okay, so now we've got our height, we've got pi times radius times height. So I have to figure out, what am I doing? Kevin, what are you doing? It's 80. It's not height, it's 80. It's literally written right there. Okay, 80. So now I need to know what the inside diameter is to find the radius. So I need to know what the cylinder is right across for the inside diameter. So I've got 20 and I've got 3 feet. I've got 3 feet here and I've got 3 feet here. So 20 minus 3 equals, anyone? Someone in the back? 14, thank you. 14 is the inside diameter. All right, 14 feet, perfect. But we need radius squared, so it is half of 14, so it is actually 7. So our radius is 7, right? 14 divided by 2, that's my radius. So pi times 7 squared times 80. Plug that into the calculator. So pi times 7 squared times 80 equals 12315.0432. Now this number looks a lot bigger. However, remember this is a 80-foot tall tank, so it should be considerably larger. And that again is in feet and cubed because we are multiplying 1, 2, 3 things together. We get a cubic feet. So arbitrarily, we're going to round to the nearest cubic foot. Why not? So 1,000 or 12,315 feet cubed is our answer. Okay. Now, of course, if you're doing a question in your workbook or in a quiz or just out in real life you can round to whatever you feel like you want to round to. In the textbook or on a quiz, follow the directions of the question. But that is it. So that's using inside volume. So whatever your tank or your cylinder is, find the inside diameter and then recognize that it is pi times r squared times height. It's the same as we've already done in previous parts. So easy peasy, right? No problem at all. See you in the next one.